In this video, I am going to talk about how to calculate pH of strong acids. Now, strong acids are the ones which dissociate 100%. So, let's say HA is your strong acid and it dissociates 100%. So, it will form H plus and A minus. Let's say concentration of acid is given to you as C. So, in this case, your HA will dissociate into H plus and A minus, and the concentration of H plus and A minus both will be C after the dissociation. Now pH, as you know, is negative log of H plus, so in your case it will become negative log of C. Now for example, let's say you have been given 10 raised to power minus 3 molar HCl solution, and if you want to calculate its pH, then you can say HCl will dissociate into H plus and Cl minus. Concentration of HCl is 10 raised to power minus 3. So concentration of H plus also will be 10 raised to power minus 3. And pH will be negative log of 10 raised to power minus 3, which becomes equal to 3. Now suppose you have been given 10 raised to power minus 8 molar HCl. Then continuing the same logic will give you H plus equal to 10 raised to power minus 8, and pH will be negative log of that, so that comes out to be 8. Now there is some problem in this particular case. Just try to pause the video at this point and figure out what is the mistake and what are we exactly missing. If you remember the previous videos, we had said that solutions which have pH less than 7 are acidic, and solutions which are having pH greater than 7 are basic in nature. So in this particular case, you are saying that on adding slight amount of HCl in water, we are going to get a basic solution, which does not make sense, right? Because the solution should be expected to be acidic in nature. But the thing that we are missing over here is that we have considered the source of H plus to be acid only, which is not very true, because H plus also comes from water, so you will also have to take that into consideration. Now again, pause the video, try to think what I am trying to say, and just try yourself to calculate new H plus concentration that you will get. The hint is you will have to take into consideration H plus which is coming from water also, apart from the acid. So as I was saying that H plus from both water as well as H plus from acid has to be considered. So now in your case, H2O will dissociate into H plus and OH minus. Now let's say X is the amount of H plus and OH minus that is coming from water. So total H plus that you will get is C plus X. Now as we know that Kw is nothing but product of concentration of H plus and OH minus. So in this case, Kw will become C plus X into X. Now you will get a quadratic equation in terms of X, which is nothing but X square plus Cx equal to Kw. Just rearrange that to give you X square plus Cx minus Kw equal to 0. Now if you solve for X, you will get minus C plus or minus root of C square plus 4 times Kw upon 2. And the concentration of H plus is nothing but C plus X in your case. So that will give you C plus or minus root of C square plus 4 Kw by 2. Now once you get your H plus, you can easily calculate pH by taking negative log of this particular value that you will get after solving the quadratic equation. Now if you can see, I have made 3 different cases where concentration greater than 10 raised to power minus 6, I can adopt the first approach wherein we directly took negative log of the concentration. In the second case, I have written that if the concentration is between these two values, 10 raised to power minus 6 and 10 raised to power minus 8, we will have to solve this particular quadratic equation. And the third case is when concentration is very low or less than 10 raised to power minus 8, we can actually neglect the H plus that is coming from acid, and we can approximately say that pH is equal to 7. So let me explain you why these are the cases that we are getting. So ideally speaking, we should always actually solve this quadratic and find the value of H plus in all of the cases. But what happens is, if the concentration is greater than 10 raised to power minus 6, the H plus that is coming from water can be neglected, and you can say that all the H plus is coming from your acid. In the second case, wherein H plus coming from water is significant as compared to H plus which is coming from acid, so that is why will have to solve this particular quadratic equation. And third case is when the concentration is very low, so at that time we can actually neglect the H plus which is coming from acid, and we can assume that all the H plus is coming from water, and in that case basically the pH you will get is 7, or basically the solution will remain neutral. Now in this video I am going to talk about how to calculate pH of strong base. Now the case is going to be very much similar to the previous one where we calculated pH for strong acid. Now let us take POH to be your strong base. So it will dissociate into P plus and OH minus. Again, because POH is a strong acid, it will dissociate 100%, and you will get concentration of P plus and OH minus to be C. Now again, as in the previous case we are going to make 3 different cases. The case 1 is when concentration of the base is more than 10 raised to power minus 6. So in this case, OH minus will be equal to C, and POH will be equal to negative log of H plus, negative log of OH minus, which is negative log of C. Once you get your pH can be calculated by using this equation, where pH is nothing but pKw minus POH. The second case is when concentration is between 10 raised to power minus 6 and 10 raised to power minus 8. So in this case again you will have to consider OH minus, which is coming from H2O. So the concentration of H plus and OH minus which is coming from water again will be assumed to be X, and total OH minus that you will get is going to be C plus X, where X is coming from water and C is coming from your strong base. Now again Kw is H plus into OH minus. So again you will get a quadratic equation in terms of X. Once you solve this quadratic equation, the value of X will be minus C plus or minus root of C square plus 4 Kw by 2, which was the same as the last case. Now the concentration of OH minus will be C plus X. That will give you concentration of OH minus is equal to C plus or minus root of C square plus 4 Kw upon 2. Using this you can calculate your pOH value, which is nothing but negative log of this particular value. Once you get that, your pH is going to be pKw minus pOH. And the third case that we are going to look at is when concentration is very low or less than 10 raised to power minus 8. In that case again we say that OH minus, which is coming from base, can be neglected, and pH can be approximately be equal to 7, or the solution will basically neutral. So more or less the case of strong base is similar to the strong acid. The only change that we are observing over here is, rather than H plus we are going to talk about OH minus, and rather than pH we are going to talk about pOH. Now let me ask you a couple of questions. Let's say you are given to find pH of these two cases, where concentration of NaOH in first case is 10 raised to power minus 3, and in the second case it is 10 raised to power minus 7. Just pause the video and try to find out the answers. You have to find pH. So now the first case is very simple, where concentration is greater than 10 raised to power minus 6. So I can directly say that NaOH will dissociate into Na plus and OH minus, and the concentration of OH minus is going to be 10 raised to power minus 3, which gives you OH minus equal to 10 raised to power minus 3 and pOH equal to 3. Then pH can be calculated as 11, because pH is nothing but pKw, which will be 14 minus pOH, which is 3. Now the second case is slightly more complicated. Now because in this case the concentration is between 10 raised to power minus 6 and 10 raised to power minus 8, I will have to use the second case that we had derived. So in this case I cannot directly say that OH minus is going to be negative log of C. Rather than I will have to solve the quadratic equation that we have derived. So if you just go back to the quadratic equation that we had calculated, we got OH minus is equal to C plus X, which was C plus or minus root of C square plus 4 times Kw upon 2. So now just substitute the values. Your concentration is 10 raised to power minus 7 plus or minus C square will be 10 raised to power minus 14 plus 4 times Kw will be 10 raised to power minus 14 upon 2. Now solving this particular equation will give you OH minus is equal to 1.6 into 10 raised to power minus 7. So if you just go through the steps that I have done, this particular bracket or under the root value will be root 5 into 10 raised to power minus 14, and you can actually take 10 raised to power minus 7 common and you will get 1 plus or minus root 5 by 2. Now if you observe, I have neglected the negative sign over here because 1 minus root 5 will give you a negative value of OH minus, which does not make sense. So we neglect that negative value and we take only positive value to be true. So if you want to find the logarithm of such values, what we can do is we can write this as 16 into 10 raised to power minus 8. Now pH will be equal to negative log of this value, 16 into 10 raised to power minus 8, which is nothing but 8 minus log of 16. Now 16 can be written as 2 to power 4. So if you take log of that, it will be 4 minus 8 minus log 4 times log of 2. So that will be 8 minus 4 into log 2 is 0.3, which will give you a value of 6.8. Now pH will be 14 minus 6.8, 14 minus pH basically, and the value will be 7.2. I hope you also got the same answer.